So for this problem, to find the value or the values for x, that this function has a maximum or a minimum value. So from this given, so first we need to find the first derivative. So y prime equals the derivative of x to the power 3. This is 3x to the power 2. So minus 1 for the exponent, then minus the derivative of 4x to the power 2. So 4 times 2, this is 8, then x, minus 1 for the exponent, so to the power 1, then plus the derivative of 4x, so just drop this x, so this is 4, then equate now this to 0, so 0 equals 3x squared minus 8x plus 4. Then from this quadratic equation, so we can use quadratic factoring to solve for x. The factors of 3x squared, this is 3x times x, and the factors for positive 4, so this is 2 times 2. So since the middle term is negative, so therefore all negative. So we have negative 2x, negative 6x, that's negative 8x. Then to solve for x, so equate this to 0. So x minus 2 equals 0. Then we have 3x equals positive 2. Then divide both sides by 3. So x equals positive 3 over 2. Then the other one, x equals transpose, that's positive 2. So these are the two values for x. Then to find the maximum and the minimum value for x, so we're going to use the second derivative test from this first derivative. So to find the second derivative, so y double prime equals the derivative of 3x squared. This is 6x, then minus the derivative of 8x, that's 8. Then the derivative of a constant, this one is 0. Then from these values for x, so at x equals positive 2 over 3. So substitute to the second derivative, so that's 6, then times x is 2 over 3, then minus 8. So we have y double prime equals 6 divided by 3, that's 2, and 2 times 2, this is 4, minus 8. So therefore the second derivative is negative 4. So since the second derivative is negative, so therefore this value is the maximum value. Then for the other value for x, so at x equals positive 2. So from the second derivative, so this is 6 times 2, then minus 8. So y double prime equals, this is 12 minus 8. So the second derivative is equal to positive 4. Since the second derivative is positive, so therefore this value for x is the minimum value. So therefore x equals positive 2 over 3 for the maximum value, and x equals positive 2 for the minimum value. Then for this given, so again, we need to find the first derivative. So the derivative of 4y, this is 4 times y prime for the derivative of y, then equals the derivative of 3x to the power 4. So 3 times 4, this one is 12, then x minus 1 for the exponent, so to the power 3, then plus the derivative of 16x to the power 3, so 16 times 3, this is 48, then x to the power 2, so minus 1 for the exponent, then plus the derivative of 18, x to the power 2, so 18 times 2, this is 36, then x minus 1 for the exponent, so to the power 1, then divide every terms by 4, divide by 4 to solve for y prime. So y prime equals 12 divided by 4, this is 3, then x to the power 3, then plus 48 divided by 4, this is 12, to the power 2, then plus 36 divided by 4, that's 9, then times x. Then equate now this equation to 0, so we have 0 equals, so observe that these numbers are divisible by 3. So this is x to the power 3, then plus 12 divided by 3, this is 4x to the power 2, then plus 9 divided by 3, this is 3x. Then we can factor out now this x. So we can put now this x outside. So this becomes x to the power 2 plus 4x plus 3 then equals 0. Then we can apply now quadratic factoring for this quadratic equation. So the factors for x squared, this is x times x. And the factors for positive 3 is 3 times 1. And these are all positive because 3x plus 1x is positive 4x. Then equate now this to 0. So we have x equals 0. Then x plus 3 equals 0. And x plus 1 equals 0. So we have now x equals negative 3 and x equals negative 1. So these are the three values for x. Then to find the maximum and the minimum value, so using the second derivative test from this first derivative, so to find the second derivative equals the derivative of 3x to the power 3, this is 9x to the power 2, then plus the derivative of 12x to the power 2. So 12 times 2, this one is 24. Then x, and the derivative of 9x, so this is 9. Then to find now the value for the second derivative at x equals 0, so we have y double prime equals 9 times 0 to the power 2 plus 24 times 0 then plus 9. So we have y double prime equals, this one is 0, this is 0. So we have positive 9. So since the second derivative is positive, so therefore for x equals 0, this is the minimum value. Then for x equals negative 3, so from the double derivative, so 9 times negative 3 to the power 2 plus 24 times negative 3 plus 9. So y double prime equals, so this is 9 times 9. So negative 3 to the power 2, that's 9. Then minus 24 times negative 3, this one is 72. Then plus 9. Then to simplify, so y double prime equals 81 minus 72 plus 9. So y double prime equals, so 81 plus 9, this is 90 minus 72. So this is positive. So since the second derivative is positive, so therefore for x equals negative 3 is also the minimum value. Then for the last value for x, so at x equals negative 1, so from the second derivative, so 9 times negative 1 to the power 2 plus 24 times negative 1 plus 9. So y double prime equals, so this is 9 minus 24 plus 9. So the second derivative equals, this is 18 minus 24. So this one is negative. So therefore, since the second derivative is negative, so therefore for x equals negative 1 is the maximum value. So therefore, x equals 0 is the minimum value, and x equals negative 3 also the minimum value, and for x equals negative 1 is the maximum value.